Okay, this is Math 2, and we're in Chapter 1. We're going to do problems number 38, part of number 40, and then number 41. So for the first one on number 38, it says, without graphing, or consider the equation y equals 1/2 x minus 4. So without graphing, we want to know where the x-intercept is. So the first thing that I really want to make sure is you actually attempt this problem without the graphing part of it, because it should make logical sense to you. So what I'm going to do first, I'm going to show you something on a graph. I'm not going to graph it, I just want to show you something on a graph. And then you'll see what I mean in a second. So if you had a graph, right, it would look something, or start to look something like this. Right? So this is your x-axis, that's your y-axis. Your x-intercept is going to touch the x-axis. So no matter where this line is, so it could be a line like this, it could be a line like this, it could be a line that's going down, or like this, it will somehow or another touch the x-axis at a certain point. Well, whatever point you pick on the x-axis, it doesn't matter where it is, all of these points have the same thing in common. The y value will always be 0. It will always and forever be 0, because you haven't risen up anywhere in the positive y values, and you haven't gone into the negative y values down here either. So all of these y values are going to be 0. Well, if that's true and they all have a y value of 0, then essentially you can substitute the y value for 0 to find out what the x value then must be. And in order for us to do that, we're just going to say, okay, let y be equal to 0. Right? Because when whatever point we find, it's going to have a y value of 0 here. So we're going to let y equal to 0, and we're going to substitute into this equation. So we have 0 equals 1 over x, 1/2 x minus 4. All right, well, if you don't really like it this way, we can go 0 equals 0.5 x minus 4, but we still need to solve for x now. So the first thing I would do is to add 4 to both sides and say, okay, 4 equals 0.5 x, divide by 0.5, divide by 0.5, so you should get x equals 8. Okay? So that means this line, wherever it might be, is going to touch this x-axis at a value of 8. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to touch it. Wait. 1, 2, 3, 4, 5, 6, 7, 8. So it's going to touch the x-axis somewhere over here. Now it says, on graph paper, make a table and then actually graph it. So a table, obviously, you can do it either way that you want. You can make a table going horizontally, or you can make a table going vertically. In either case, I would recommend, just because it's me, starting -1, 0, 1, 2, and 3, and that should give you a pretty good idea of what your points will look like. And then graphing wise, it should look like, let's see, -4, 1, 2, 3, -4, and then we're going to up 1 over 2, right? Okay, good. And it should look 1 over 2, 1 over 2, 1 over 2. It should look like this when you finish your line. There you go. It should look something like that. And then using your graph from part B, how can you find the x-intercept of the equation? How do you find it in a table? Explain. Well, your x-intercept would be when the y would be 0. So I would say keep looking for it, right? If you keep looking on the table, 4, 5, 6, 7, 8, when you plug in the 8 to the equation, you should actually end up with a 0 for the y. And that's how you know you have your y-intercept. Your x-intercept. Okay, that was number 38. Number 40, I'm not going to do too much with this. The only thing I will give you is partial hints. Please make sure you put a 1 underneath the 6. That will probably make your life a little easier. And then for part B, I would just strongly recommend you put parentheses around the 5x plus 9, because I do not want you to make a mistake and forget that there's a plus plus 9 inside that top. The whole quantity on top needs to be taken care of at the same time. Okay? And then on number 41, which is what I really wanted to get to, it's kind of a different problem, but it's doable. It says Sandy and Robert each have various polygons in their bucket. See below. So Sandy's got 4 polygons. Robert has 1, 2, 3, 4, 5, 6 polygons. Sandy randomly selects a polygon from her bucket, and Robert randomly selects a polygon from the bucket. What is the probability of selecting a quadrilateral? Who has the greater probability of selecting a quadrilateral? And then who has the greater probability of selecting an equilateral polygon? And then what is more likely to happen? Sandy selecting the polygon with at least 2 sides that are parallel, or Robert selecting a polygon with at least 2 sides that are equal. Oh, this is complicated. Well, it's not complicated. It's just, it is what it is. So let's see. Sandy has a probability of selecting a quadrilateral. So out of her 4 shapes, which ones are quadrilateral? So equilateral triangle, obviously not 4 sides. Hexagon has 6 sides, so that's not 4 sides. Square has 4 sides. Rhombus has 4 sides. So the probability for Sandy for collecting or selecting a quadrilateral would be basically 2 out of 4, because she's got 2 quadrilaterals and 4 total polygons in her bucket. For Robert, let's see, that would be a triangle. Trapezoid has 4 sides, so there's 1. Try another triangle. A kite has 4 sides, and a quadrilateral obviously has a quadrilateral. So he's got 3, trapezoid, kite, and quadrilateral. So he's got a 3. I'm going to use a different color. So he has 3 out of 5. So the question is, which one of those is bigger? Because we want to know. Now, if you're just sitting there and you're like, I'm just going to let her do it. Okay, that's fine. But you still should probably figure out which one's bigger. 2 out of 4 is basically just equal to 1/2, which is just equal to 0.5. Right? So she has a 50% chance of picking one out of her bucket. Robert, on the other hand, a 3 out of 5, that obviously I can't simplify anymore, but 3 out of 5 has a equal to, as a decimal, 0.6. So technically he has a 60% chance versus Sandy's 50% chance of actually selecting a quadrilateral. So who wins? That would probably be Robert. Right? That's 50% here, and that's 60% here. Okay, now the next one, who has a greater probability of selecting an equilateral polygon? So you're looking for something that has every side the same. A square, okay, that has every side the same. Rhombus, that actually also has every side the same. It's just a square kind of tilted. Equilateral triangle, obviously it's equilateral, so there's 3. And then a regular hexagon, well, I hope you remember what regular means. Regular means all sides are equal, all angles are equal also. So that's a equilateral polygon too, because it's all the sides are the same. So technically Sandy has a 4 out of 4 chance of getting something out of her bucket that has 4 equal sides, or all the sides are equal. Robert, on the other hand, has a scalene triangle, so that just means none of the sides are equal. Isosceles only 2. Isosceles still only 2. A kite, no, that doesn't have equal sides. A quadrilateral, no, that doesn't have an equal sides. It's just something that has 4 sides. It could look like anything. So he technically has 0 out of 6. Well, I don't need to tell you that 0 out of 6 is just 0. 0.0 if you really want to do that and just go 0%. Okay? 0 out of 6 is just 0. 4 out of 4, well, that's just 1. Or in this case, that would be 100%.
Vanessa Mesa, please come to the front of the school. Vanessa Mesa, please come to the front of the school.
Okay. So the question next is, what is more likely to happen? Sandy selecting a polygon with at least 2 sides that are parallel. Okay, so let's figure out what that is. 2 sides that are parallel. Okay, well, a square has parallel sides. Okay, a rhombus has parallel sides. just look at the picture in the polygon organizer that we did a couple of days ago. Equilateral triangle, no parallel sides. And regular hexagon does have parallel sides. So she actually has a 3 in 4 chance of getting a polygon with at least 2 sides that are parallel. So that basically turns into 0.75, or better known as 75%. Now, Robert, selecting a polygon with at least 2 sides that are equal. So let's see, 2 sides that are equal. Okay, scalene, none of the sides are equal. Isosceles, 2 sides are equal. Right isosceles triangle, 2 sides are equal. A kite, 2 sides are equal in the kite. And then in the quadrilateral, we don't know. It could be anything. So he has 1, 2, 3. So he has 3 out of 6 chance of actually getting, so that's 1/2, so, or better known as 0.5, and then 50%. Okay? So the likelihood will be more that Sandy selects a polygon with at least 2 sides that are parallel than Robert. All right. Hopefully that explains some things on number 41. I will see you guys later in class.